We are capable of crafting tables and chairs, of firing teacups and teapots, yet we are unable to manufacture a single automobile, a solitary airplane, a tank, or even a tractor. This was not a statement of false modesty delivered by a modern politician attempting to lower expectations before an election cycle. It was a stark, unvarnished admission of industrial impotence delivered by Mao Zedong, the architect of the People's Republic of China. When Mao spoke these words in the early 1950s, he was not just being dramatic. He was diagnosing the vital signs of a nation that had effectively flatlined. China had emerged from a half-century of unrelenting chaos, from the fragmentation of the warlord era to the brutal, grinding attrition of the Sino-Japanese War, which bled seamlessly into the global inferno of World War II, and finally the fratricidal violence of the Chinese Civil War. The result of this relentless conflict was an industrial landscape that was not just damaged, but practically non-existent. To say industrial output was zero was not hyperbole. It was the terrifying daily reality of a nation that wished to be a superpower, but lacked the ability to cast a single engine block or forge a high-strength steel beam. To the nascent republic, this inability to build the machines of modernity was not just an economic problem. It was an existential threat. It was an intolerable vulnerability that invited future subjugation by powers that could build tanks and planes. Driven by this desperate need for self-preservation, the Chinese leadership broke ground in 1955 in the ancient city of Luoyang, Henan province. This was the birth of the first tractor plant, a project of monumental symbolic importance. 3 years of frenzied construction later, in 1958, the factory doors rolled open to reveal the Dongfang Hong, or the East is Red, China's first domestically produced tractor. The name was a declaration of intent. The East would rise, and it would be built by Chinese hands, powered by Chinese engines, and driven by Chinese farmers. Crucially, right next to this tractor plant, the state commissioned another facility, the Luoyang Bearing Factory. At the time, it seemed like a mere support facility, a secondary concern. But, as we will discover, this factory produced the very joints of modern industry, ball bearings, and it remains central to our story today. These projects were the crown jewels of the 156 initiatives that comprised China's first 5-year plan, the opening salvo in a 70-year war to transform an agrarian society into an industrial leviathan. This plan was not merely about economics, it was a survival strategy, modeled heavily on the Soviet Union's rapid industrialization, which Mao viewed as the only template capable of saving China from irrelevance. Fast forward 7 decades, and the transformation is arguably the most significant economic event in human history. China now stands as the world's second largest economy and a military peer to the United States. It is the world's factory, a moniker that barely does justice to the scale of its output. From the smartphone in your pocket to the steel beams in your office building, the supply chains of the world run through Beijing. The sheer volume of production is staggering. China produces more steel, more cement, and more ships than any other nation on Earth. It has built the world's largest high-speed rail network and boasts the most active patent office globally. Yet, beneath this armor of industrial dominance, there are cracks, serious structural cracks. China suffers from dozens of what experts call industrial chokepoints. These are specific, high-tech bottlenecks where China is still dangerously dependent on the West. Beijing knows this, Washington knows this, and celebrates it. These chokepoints are the invisible noose that the United States holds, a mechanism to choke off China's rise to total supremacy. What exactly are these chokepoints? Why, after 70 years of development and trillions of dollars in investment, does China still struggle to make certain specific components? Can they close these gaps, or will they forever be the Achilles heel of the Chinese dragon? And ironically, is the United States inadvertently helping China solve the very problems it hopes to exploit? Today, we are going to look under the hood of the Chinese economic engine to explore the fragile parts that could cause it to seize up. Before we dissect the geopolitics of industry, I want to welcome you to Ecom Empire. We are dedicated to uncovering the hidden mechanics of the global economy, the wars fought not with soldiers but with supply chains, and the empires built on trade. If you appreciate deep dive analysis that goes beyond the headlines, make sure to subscribe and join our community. In May of last year, Chinese President Xi Jinping made a pilgrimage back to that industrial cradle in Luoyang. He toured the Luoyang Bearing Group, the modern descendant of that 1950s factory. Standing amidst the hum of precision machinery, Xi delivered a message that was part history lesson, part battle cry. "We have come a long way," he told the assembled engineers. "We went from importing matchsticks to being the world's largest manufacturer. But we must persist. We must master the core technologies ourselves." Why did Xi choose a ball-bearing factory for this speech? To understand the symbolism, we have to understand the man and the history he carries. Xi Jinping is a product of 2 eras. His father, Xi Zhongxun, was a revolutionary comrade of Mao who was sent to Moscow in the 1950s to learn how to run a state industry. The young Xi grew up in the shadow of the Soviet model, the belief that heavy industry and state planning were the keys to power. He witnessed the peak of Sino-Soviet cooperation, where Russian engineers helped design Chinese factories, but Xi also saw what happened when that model failed. When the Soviet Union collapsed in 1991, Xi was rising through the ranks of the Communist Party. He studied the Soviet disintegration obsessively. His conclusion was that the Soviets failed not just because of political liberalization, but because they became technologically stagnant and economically brittle. They relied too heavily on oil exports and failed to modernize their civilian manufacturing base. They could build missiles, but they couldn't build microchips or reliable consumer goods. When Xi took power in 2013, his strategy was initially cautious. He wanted to avoid the Soviet fate, but he didn't feel ready to challenge the American hegemon directly. Then came 2016 and the election of Donald Trump. The Trump administration launched a trade war that shattered the illusion of economic cooperation. Tariffs were slapped on Chinese goods, and Chinese companies were placed on blacklists. For Xi, this was the moment the mask slipped. He realized that the United States would not passively allow China to rise. It would use every tool at its disposal to strangle Chinese growth. In response, Xi shifted gears. He moved China from a strategy of peaceful rise to a strategy of comprehensive struggle. The goal was no longer just to get rich. The goal was to achieve strategic invulnerability, a state where no American sanction could hurt the Chinese economy. He launched initiatives like Made in China 2025, which explicitly targeted dominance in high-tech sectors. This is where the concept of choke points moved from engineering manuals to national strategy. In 2018, the state-run Science and Technology Daily published a brutal self-assessment, a list of 35 distinct technologies where China was hopelessly behind. This was unprecedented transparency for a regime that usually hides its weaknesses. Analysts in Washington, including former CIA linguist Ben Murphy, translated these articles and realized they had a roadmap of China's fears. The list included obvious things like high-end semiconductors, chips, but also obscure items, heavy-duty gas turbines, high-pressure hydraulic components for excavators, tactile sensors for robotics, and crucially, high-end ball bearings. Let's focus on those bearings. It sounds mundane. A ball bearing is just a steel sphere that reduces friction, right? Wrong. In the world of high-precision manufacturing, a bearing is a technological marvel. We are talking about spheres that must be perfectly round to within a millionth of a meter. They must withstand immense heat, pressure, and rotational speeds without deforming. If a bearing in a high-speed train traveling at 350 km/h has a microscopic imperfection, it generates heat. That heat leads to failure, and at those speeds, failure means catastrophe. The metallurgy required to create bearing steel is incredibly complex. It requires removing almost all impurities, oxygen, titanium, sulfur, from the steel. If even a tiny particle of oxide remains, it creates a fatigue point that will eventually crack. For decades, Chinese steel mills couldn't achieve this purity. They could make steel for bridges, but not for precision engines. The global market for these high-end bearings is a closed club dominated by 6 companies: Sweden's SKF, Germany's Schaeffler, and Japanese giants like NSK and NTN. These companies have guarded their trade secrets for a century. China makes billions of cheap bearings for skateboards and washing machines. But when it comes to the bearings needed for jet engines, CT scanners, or precision robotics, China imports almost all of them. This is a choke point. If the West decided tomorrow to ban the export of high-grade bearing steel to China, the high-speed rail network, the pride of the nation, could grind to a halt. But China does not accept vulnerability gracefully. The state has mobilized its entire apparatus to solve these problems. In the outskirts of Hangzhou, at a company called Deep Vision Technology, a quiet revolution is underway. A team led by engineer Wang Shuilei is attacking the bearing problem not with better steel, but with better eyes. They have developed an AI-driven computer vision system capable of detecting surface defects as small as 2 micrometers. Traditionally, checking bearings was a manual or semi-automated process prone to error. By integrating artificial intelligence into the quality control process, Deep Vision is trying to leapfrog the decades of institutional knowledge held by German and Japanese masters. This is the Chinese playbook. When you cannot beat the West at traditional manufacturing, you change the game by adding AI. By using machine learning to analyze the microstructure of the materials, they are improving yields and quality at a rate that Western competitors find alarming. Executives at major Japanese bearing firms have admitted to the Financial Times that while China still lags in design, their manufacturing consistency is catching up at a terrifying speed thanks to this digital integration. We see this pattern repeating across the board. Take the choke point of lithium battery separators. A battery separator is a thin membrane that sits between the anode and cathode. If it fails, the battery short circuits and explodes. 10 years ago, China imported all of these membranes. It was a critical weakness for their electric vehicle ambitions. Today, companies like CATL and BYD dominate the global market. They didn't just copy Western technology, they improved it, scaling production until they drove the price down so low that Western competitors couldn't compete. Take LiDAR, the laser eyes of self-driving cars. Early LiDAR systems were clunky, expensive spinning buckets that cost $75,000 each. China identified this as a future strategic technology. They poured billions into startups, subsidized research, and created a massive domestic market for EVs. Today, Chinese companies like Hesai lead the world in cost-effective solid-state LiDAR. They turned a choke point into a spearhead. However, some choke points are stubborn. Carbon fiber is the classic example. This material is lighter than aluminum, but stronger than steel, essential for modern aerospace, centrifuges, and high-performance missiles. The manufacturing process is a dark art involving complex chemical reactions and precise heat treatment of polyacrylonitrile, PN fibers. A single Japanese company, Nikiso, controls a vast swath of the high-end market. Despite throwing money at the problem for 40 years, China still struggles to mass-produce aviation-grade carbon fiber that meets global safety standards. This remains a gap that keeps Chinese commercial jets, like the C919, dependent on Western suppliers for their composite parts. But the biggest battleground, the mother of all choke points, remains semiconductors. This is the oil of the 21st century. Almost every modern weapon system, from hypersonic missiles to radar arrays, relies on advanced chips. The United States has recognized this dependency and has weaponized it. Through the Foreign Direct Product Rule, the U.S. has effectively banned the export of the most advanced chip-making tools to China. This includes the extreme ultraviolet EUV lithography machines made by the Dutch company ASML. These machines are the most complex devices ever built by humans, capable of printing circuits just a few nanometers wide. Without them, you cannot make the chips that power the latest iPhones or AI servers. In response, Huawei, a company the U.S. tried to kill, has reinvented itself as the coordinator of a national resistance. Huawei was placed on the U.S. entity list, effectively cutting it off from Google's Android and TSMC's chip foundries. Most experts predicted Huawei would die. Instead, it pivoted. It began investing in dozens of obscure Chinese companies that make optics, chemicals, and lasers. In a meeting with President Xi earlier this year, Huawei founder Ren Zhengfei, an 80-year-old former army engineer, pledged that a coalition of 2,000 Chinese companies would achieve 70% self-sufficiency in the chip supply chain by 2028. This is a mobilization on the scale of the Manhattan Project. Huawei recently shocked the world by releasing the Mate 60 Pro smartphone, powered by a 7-nanometer chip made in China by SMIC. While still behind the cutting edge, it proved that U.S. sanctions had failed to stop Chinese progress. They had merely slowed it down, and in doing so, they forced China to build a parallel supply chain that is completely immune to U.S. law. The irony of the American containment strategy is that it has awakened a sleeping giant. By denying China access to technology, the U.S. has removed the easy option. Before the trade war, Chinese tech giants were happy to buy chips from Intel and Qualcomm. It was cheaper and easier than making their own, but when the U.S. weaponized those chips, the calculation changed. Buy versus build became a matter of national survival. Just recently, Donald Trump, in a pragmatic reversal during his campaign rhetoric, suggested he might allow NVIDIA to resume selling certain AI chips to China. Why? Because NVIDIA argued that if they couldn't sell to China, Huawei would simply fill the vacuum. If Chinese companies are forced to use Huawei's Ascend AI chips because they can't buy NVIDIA's H100s, then Huawei gets the revenue, the data, and the ecosystem lock-in. The U.S. risks creating a competitor that eventually eats its own lunch. It was an admission that the window to strangle Chinese tech is closing. The numbers tell the story. In 2024, China spent $500 billion on research and development. They are pouring capital into little giant firms, specialized startups designed to solve specific choke point problems. These aren't the massive conglomerates like Alibaba. They are small, nimble engineering firms that specialize in one thing: a specific hydraulic valve, a specific type of laser, a specific chemical photoresist. The state provides them with tax breaks, cheap loans, and guaranteed contracts. The message to Chinese scientists is clear. We don't care about short-term profit right now. We care about sovereignty. If you can solve a choke point, you will be heroes. So where does this leave us? We are watching a tectonic shift in the global order. The era of globalization, where efficiency mattered more than geography, is dead. We are entering an era of industrial mercantilism, where nations fight to control every link in the supply chain. China is racing to close its last few vulnerabilities before a potential conflict, perhaps over Taiwan, makes them fatal. The United States is betting that its alliance network, Japan, the Netherlands, South Korea, can keep China boxed in. It is betting that the complexity of modern technology is so high that China simply cannot catch up alone. China is betting on its scale, its engineering talent, and its sheer will to survive. It is betting that a nation that built the Great Wall can build a lithography machine. The question for the rest of the world is simple. What is our plan? We consume the cars, the phones, and the tanks, but most nations do not make them. We are observers in a titan struggle. China realized 70 years ago that a nation that cannot make its own tools is a nation that will eventually be ruled by others. As we watch the world's factory retool itself for a new century of dominance, we have to ask if we are content to remain merely customers, or if we too need to look at our own industrial capabilities. The story of the Luoyang bearing factory is not just history, it is a warning. It tells us that industrial power is not granted, it is seized, it is forged in the fire of necessity. And right now, the furnaces in China are burning hotter than ever. If you found this deep dive valuable, please subscribe to Ecom Empire and share this video. The algorithm may not like these long-form analyses, but your support keeps them coming. Let us know in the comments. Do you think China will overcome these choke points, or will the US containment strategy succeed? I will see you in the next episode.